Okay, so we're looking at question 8 of the 2014 exam. So by introducing slack variables and artificial variables as appropriate, and using the two-phase method, we aim to write down the first tableau of the simplex algorithm of the following LP problem given here, and we write our answers in this tableau provided. And finally, we have to circle the entry that we'll pivot on. Okay, so I'll firstly just underline this one, just because it's very easy to forget this after you've done a bulk of the work completing the tableau, and if you know what you're doing, that should be easy enough and it's 3 marks. Okay, so the first thing we need to look at is to get the constraints that we're given into the appropriate form so we can enter them in the tableau given of the greater than or equal to signs, and make sure that they're positive. And in this case, we just need to fix up the first constraint that's given to us. So what we do is multiply both sides of this inequality by -1, and that'll give this as a non-negative number, namely 11. So let's do that now. So we have x minus 2y minus 2z is less than or equal to 11. Okay, so now we have that condition that both of these numbers are non-negative numbers. Okay, so the next step is to look at these inequalities here, and we aim to change these signs, namely greater than or equal to signs and less than or equal to signs, into equal signs. So how we do that is by introducing slack variables and artificial variables. Okay, so let's look at the first constraint that we're given. So that is x minus 2y minus 2z, and then to convert this from a less than or equals to sign to an equal sign, we need to introduce our first slack variable. Now note, because it's less than or equals to rather than greater than or equal to, we don't need an artificial variable here. So let's just introduce our first slack variable, which we'll call S1, and then make it equals 11. Okay, so now for our second constraint, we have 3x minus y plus 7z, and because we have a greater than or equal to sign, we'll need our second slack variable, and we'll also need an artificial variable as well. So in this case, we have to take away our slack variable, or make its coefficient -1, and then add an artificial variable which we'll call r, and then make that equal to 1. Okay, so this inclusion of r here is to get this set of constraints in canonical form. Otherwise, if we were just left with a minus s2 and a plus s1 without the r making an appearance, it won't be in canonical form, and hence we wouldn't be able to use the simplex algorithm on our tableau. Okay, so the next step of the problem is to give ourselves a maximization problem, which will be the first phase of the two-phase method. And we aim to maximize w, which we let equal to minus r. And we do this because in the end we want this artificial variable r to be equal to 0. So then we can continue by doing the second phase of the two-phase method, which is this maximization problem up here. Okay, let me just write out what minus r is equal to. So that's equal to -1 plus 3x minus y plus 7z minus s2. Okay, so now we've got our maximization problem for the first phase here. So we're ready to complete our tableau. Okay, so let me just write in the variables up here. Okay, and now we can start filling in the entries of our tableau. So firstly, for the first row, we'll use our first constraint, which is fairly intuitive. So the coefficient in front of x for this constraint is 1, for y is -2, -2 for z, 1 for s1, and 0 for these two, and we have a value of 11 at the end there. Now for the second constraint, I'll do this a bit quicker. We have 3, -1, 7, 0, -1, 1, and 1. Okay, now for our Q row, we need to look up here for our Q objective function. So we have the corresponding values -2, -2, 7, and then 0 for the remaining entries. Okay, so let's quickly have a look at what our basic variables are. So for the top row, we have S1 is our basic variable, and R for our second row. So I do that first, just so it's easy for us to fill in our W row down here, as W is equal to -R. Okay, now I mentioned that first before we do the W row, just because, as we can see up here, we have W is equal to -R, so our W row is simply our R row multiplied by -1. So for this value down here, it's 3 multiplied by -1, this value is -1 multiplied by -1, and so on. Okay, so we've completed our tableau, which is very nice. But there's one final thing to do, which is up here. We have to circle the entry that we pivot on. So how we do that is initially we have a look at the most negative number down in our W row here, which is -7, and then we have a look at these corresponding ratios here. So we have a look at the ratios 11 on -2 and 1 on 7. So we have to choose the least non-negative ratio out of the two ratios. Now as this is a negative ratio, the ratio we're after is 1 on 7. So hence the value we pivot on is this value of 7 here. So we circle that one. And that's it for this question.